I think, at least if you are a bit inclined in computer science and you worked even at school about with databases, you'll ask yourself why there are no databases written in Java or in C# or in JavaScript for that matter. And if you look a bit deeper, you'll find a few of them. And you say, then the question why there is no big database written in C#. Because there are like H2, DB4O, LightDB. If you use something like NoSQL or similar with NoSQL database, or you may find that some people port the SQLite to C#, which is .NET. So the why there are no big database vendors, and why all of them seem at least to look to not use at all anything but C++ or something like that. And I think let's go on the deepest issue, I think, at all, is that when you talk a big database system, especially a large one, it has features which are really expensive to implement. It's simple as that. And database vendors which implement them, they really trump everything in revenue. Like the first 5 database vendors, I'm talking Oracle, IBM, Microsoft, SAP, which had the Sybase implementation and Teradata, their revenue gets more than 94%. So whatever you would implement of excluding, you'll start probably 20 years later, but of course you will cut some corners because you start later, you have the hindsight view. You can get at most 5.7% at least now, assuming the companies will not renew the contracts and so on with the other option. But also you are competing with free vendors, and I'm talking here about MySQL or Postgres, which they have also support options, which will cut deeply into your big hopes to do a large database system. And also what it's a bit more important, and again this is a business talk mostly, that this slide at least, is that it has many things into it. So you have to have ACID. ACID, it's an acronym, and basically what it means, you have to have transactions and rollback. And to have this, you have to implement something like a transaction log, and also to extract some parallelism. You have to have reliable performance, and there is this at least perceived view that virtual machines, they don't have reliable performance because they have a garbage collection which can freeze your app. I think this is not fully true, but the perception at least is that it's not giving to you the right performance. And also you'll have to fight that sometimes the virtual machine doesn't give to you as good code, generated code, than a C++ compiler would do. So when you'll compete with another vendors, side by side you'll look bad, assuming you have implemented the same feature in the same way. This one I think is not true, but it's very recently not true, to be fair. So people will argue what's the defining line, but I would say for Java, I would say Java 8 with its tiered compiler in the Oracle's Java implementation has the baseline, which is very similar with C++. And in the .NET world, it will be in December 2019 with the .NET Core 3.1 runtime. This will be kind of the matching points when you will say, I don't care so much about the gap in runtime performance. But there are there are some things to talk. So for example, if you implement today in C++, M1 the Apple's or M2 processors are still very well supported, but they are quite badly supported by Java. And .NET, I think 3 days ago, they said they would have better performance on an ARM-based CPU compared with an Intel one. And so I'm saying that it's not as simple as that, but I'll say it's mostly addressed, but very recently. So whatever you were competing, you will not compete in performance. On top of that, the databases typically, for bad reasons, they support only the SQL syntax for doing select, like you select from, where, and there you can get your necessary data. But the stored procedure itself, it has a custom syntax. So the most known syntax is probably PL SQL, the Oracle's one. It looks like Pascal. And if you know PL SQL, you can transfer this knowledge to DB2 and so on. You can transfer that to MySQL. In fact, you can transfer from MySQL to Sybase because they use, for historical reason, a very similar version. But in general, if you make your own database, people will ask, do you have stored procedures? And you have to say yes, you have to implement them. And you should have a syntax that most people would use. And this is some work. And on top of that, you have to support other external factors like whatever is named a client. And this one is typically you'll have to take your binary protocol or something like that. You should add encryption, you should add specific drivers for Java and .NET and so on. But what I'm saying, it's a lot of work to make even a very basic, reasonable competitor to a big database vendor. So assuming you are considering is done, which challenges would you have? And I think the biggest one is that there are targets which you still can't touch. And one of them is, let's say you have a small database, few hundreds items maybe. It's like a phone or a notes application. And if it's especially on mobile phone, there is no point to implement it yourself. There is SQLite. If you can access the disk, why not use a JSON serializer and you just keep everything in memory? And this one doesn't make you, not you, the user, to take into account your database. What is even worse is that virtual machines, they have by default a small overhead. I would say some people will argue how small is small, but let's say 16 megabytes is quite common to have as an overhead for a small Java machine like IBM's one, OpenG9, and probably again kind of 8 megabytes or something like that for .NET. And on top you put the garbage collection, that it keeps some extra data around. You may have bigger frameworks initially. And this is the first one. So probably you'll have to target at least a medium machine or a higher end machine. So on top of that, you have to think on something. So let's say you define your client, which has a binary protocol. For the sake of argument, we can take advantage on the fact that the developer uses a high-level platform. So probably you could use JSON because it's very well integrated in these high-level languages. Or the very common one is today gRPC, the Google's one, and or Thrift, something like that, and you communicate between processes. And you give just basically your SQL driver makes a JSON, and that JSON is decoded back and is given back and forth some JSON files. So the protocol is very easy, to be fair, to be implemented. But after that, whatever especially changes done, you have to write it on a file, and that file, there should be a discussion, should be memory mapped file, but let's say it is or it isn't, your choice. But then you have to make sure you extract parallelism. So basically, if you have queries, you'll have to make them as possible to run as many cores as possible. And then you'll have to make sure when there is a transaction which mutates, to give clear to the query that state, whatever, to have the state not changed. So underneath the query is changed, but you make a copy. In fact, this would be a bit easier, I think, if you use a virtual machine, because the garbage collection could keep track of the old copy. You just have a reference, but you'll have to do something which is named materialization. So basically, you have to copy in memory this data and in a way to give it back when it's not needed. And the bad part is that, for example, in C++, you can use a buffer and you just free it at the end. You can give to allocator a buffer and you can say, typically last query used, let's say 12 megabytes of memory. I can give 16, so very likely it will not overtake that chunk. And the garbage collection doesn't have a free method, obviously, because that's the point of garbage collection. So it can give to you some caching issues. So there is some talk, especially if you work on a virtual machine that doesn't have too good tuning, that probably some parts should be put out of heap. And again, a person should work with a memory mapped file, which will make it a bit harder to work. On top of that, the company which would implement that obviously has to implement a store procedure. And let me talk what's so important about store procedures if you didn't come from a database view. So let's imagine, for the sake of argument, that our critical data is in Australia and I live in Europe, let's say Central Europe. So my banking system wants to buy a book, and it goes to the database in Australia because I have my database which works like a warehouse, and it works with like Amazon, let's use this name. So I want to buy a book. So when I go to that vendor, it says how many books it has, and it just happens that I buy the very last book of that very famous author. And when I'm buying it, technically, if another customer comes to that vendor, should not only see that the book was sold and so on, but also maybe the author, because the author has just one book, at least in that store, to be removed. So a store procedure, what would do, would listen when, for example, a delete happens, what would remove that specific row where you say a book was removed, and it will look, is it the last book of the author? And if so, it will also delete the author too. And the question is, why would you do it in a database? Some people would ask, and the reason is multiple-fold, but the most important one is that it's much faster to execute in the database, because you'll not ping back and forth, and the ping could be half of a second or more. And to have zero ping, basically, when you delete one user, in fact, another query will execute. So this system has to create kind of transaction, and this is also some logic that has to be implemented. What it will be still very easy, it will be a easier way to implement a compiler, parser, debugger, probably in a higher level language than in C++ or C, and also to clear up memory and to not have leaks. but this is doable. I think this is not the biggest cost, but language that supports this kind of stored procedures is quite complicated to be made. Especially if you want to make it performant, probably you'll have to have some integration with the virtual machine. And after you do that, there are more challenges. The important one is that to have at least a good performance, you have to have something which is named a query planner. So you write a select, and if the select is non-trivial, don't check if users equals 25, which is an ID, but you check that both the user and the age and the department, and you put a join there, the complexity of the queries increases drastically. So typically there is a simple compiler or complex compiler, depending on how much time you have and how big the company is, to first of all to see which query is the most advantageous to run, to check, because if you make a faster check first, your query will do less per item. Then you may want to see that to use indexes, so probably you should firstly check into an index, and if the person didn't index at all, to even to suggest as a warning. But even if you don't suggest, at least to time it. So you'll have to have this kind of semantic. If your queries hit very often one specific index, most of database systems will keep it in RAM. And obviously if you keep it in the Java heap or something like that, this will give you performance implications. So this is another issue. The other part, the query itself, the expression to filter with in a typical select kind of read, it has to be optimized. And what is surprising for some is that, for example, Oracle's query planner is written in fact in Java, and my understanding, but I never worked for Oracle, is that it let the Java optimizer to optimize the code natively, but itself it has its own optimizer on top. So I'm saying this could be done, but there are performance implications to write it. And on top of that, let's say you have all this structure, all this architecture where you get logs, you see one are deleted, inserts, and so on. You call your stored procedures. Maybe they would be precompiled natively live into the Java code, and you get a jar and you execute that class with reflection. And you have a query planner which will simplify some of the expressions, and you solve your caching of indexes. There are some parts that even like that will not be competitive if you don't run parallel. So you can simple selects, you can do queries, but as you execute queries behind your back, there are at times, especially on a larger system, code which makes changes, and some selects. So if a user changes the name, his name, because whatever, it shouldn't affect the book selling, which I was talking earlier. And all the queries around the name, insert, and so on, they shouldn't lock each other. They shouldn't give any rollbacks or so on. But on the other hand, if you are on that store and some other user just buys the last book, you should kind of get a notification, or when you try to buy it again yourself, you should get a transaction failure transparently for you, and you should have some ordering. So this is complicated to be done, and on top of that, There are other talks like replication, like you have a secondary node which would run the same query or will be just a shadow of you, and when you go down as a node forever, whatever, your disk dies. You want to write on disk and your disk says no, that all the requests will fall back through to another node. So there are more problems to be done. There are, though, very simple problems to fix, like when you talk with your system, like your implementation. Typically, a database system works through a network port. It writes some logs to disk, and all these APIs are very fast. There is some part like you may work through a port, and this code is not optimal. It will do some what is named marshalling, but this should never be a bottleneck, especially on a larger system. But what is a problem, I think, is that it's what I was saying is the SQL vendor syntax. So probably a lot of work should be done, that if a person mistypes some of the syntax and it looks like it's clear that this guy was trained from Oracle system, and you make your PL SQL, but it doesn't have an exact equivalent in your RDMS, you should give a warning or something like that. And this takes a lot of work to make it right. The other issue I was talking, it's about just in time, the like VMs, they have a very good code generator today, but sometimes it's not too good. Like very important now, as of if you want the hottest topic in performance about just in time, most of them they support what is named SIMD, like they can support this wide instruction processing multiple items at once. It has to be specially written code, but this code was kind of for forever written in C++. So you may need to port this kind of code, or you may need to call a C++ routine underneath, and this increases the work. And at last, let's say you have your own very good, or fast enough at least, system. This is not all the work that is there. One part you should do is that you should know that someone will use your code. And obviously, if the person uses just JSON directly, there is no work to be done. But many people, when they would want a SQL system, they will want a high-level abstraction. Or sometimes it's named, maybe you had ORM, like you want to really to do an insert. You basically say table.add, and you add one instance, and it will create inside it whatever SQL query that is necessary to insert. It will do the insert statement for you. It will do updates when you change a field and so on. So there has to be at least some validation against frameworks like Hibernate or Entity Framework or Liquid to SQL or things like that. Okay, so I think this kind of sums up was the performance about. But if you'll take, this is kind of a hypothetical future, but let's talk that in fact some people may miss that there are VM related runtimes, and I made some mistakes on the last slide. I will not remake the slide, sorry, but the topics remain the same. So for example, the H2 database is today in fact for simple queries, very competitive. So it's, as far as I know, and I'm convinced I'm wrong, you can do all the ACID things. I don't know which store procedure operation they do support, but what's very good about H2 implementation is that it works both to be wrapped as a outside database, but it supports also to embed it in your application. And this one removes all the overheads of protocol, of you still write queries, but the queries are basically inside your process, and it is very fast for this reason. The other way I've seen attack the VMs problem, it's that there is no database, or it's a NoSQL database, which has fewer restrictions around multi-core. LightDB, for example, in .NET, it works more or less like SQLite, but it stores objects or whatever it's named. Basically, it stores a JSON. The other projects, and initially I put them in 2 lines, then I put in 1 line, and I forgot, and I copy paste wrong. The Apache Hive and Apache Spark, you should look for both of them. They are special query languages on top of large data sets. And what they do, in fact, Spark, as far as I understand, works on top of databases like MySQL, and Hive, they don't. It's a big Java system to query Hadoop, if I remember right. So it's a MapReduce framework, and both of them, they solve the issue of having a SQL-like syntax on top of systems much bigger than maybe a traditional database with clustering and replication would need. So you'll still have replication and clustering, but the operations are automated at another level, and you'll still have the SQL syntax on top. But the last part, which I want to say that it was a huge success, is Apache Kafka, and some people scream correctly that Apache Kafka has nothing to do with databases. It is a MQ, message queue kind of system. Why it's there? And the reason is that some people use databases just for their ACID reliability. They want a transaction, they want to be always an append-only structure, and they would use a database because database is very well optimized for append-only. And obviously, I'm not saying you should work like this, but for this ones, Apache Kafka is the message queue that is, it has the capacities of this high I would say high end, to say so, operations. Like it's a message queue which supports replication. You can have multiple nodes, some of them will fall and so on. So what they do, they, in a way, all these projects, as far as I see from what I'm standing, but they're not the only one. Some people say DB4O is another one. So I may miss 1 or 2, and it's not intentional. But all of them, they make less and less necessary a big, expensive, large database system, or when they need it in a much smaller capacity. The other part, which I think it also is important, is that I think both, especially the .NET and Java runtimes, which I know them quite deeply, and Java, they have multiple implementations, but both of them, they require still some extra oomph to be very competitive in the last 5%. Especially .NET Core, I think it needs a tiered compiler. It has one, to be very clear, but it is still promised for some years about having something which is named on-stack replacement, which is not there. And so .NET definitely has some gaps, and Java has, for example, this on-stack replacement, but Java doesn't have what is named Project Valhalla or value objects, which .NET has. So both of them should copy from each other. I'm not saying copy maybe is the wrong word, but you understand the idea. And the other part is that I think that the many of these small toy databases or projects, they in fact make the big databases unnecessary. Again, excluding when you have a very high-end workload, but when it's a small workload, excluding, as I said, like you can write a JSON with millions of entries in few seconds probably. You may not need, especially if you can keep everything in memory. And today we have a lot of memory. My laptop has 64 gigs of memory. Obviously this is a high-end laptop, but I'm saying you can use half of gigabyte maybe if your app needs this kind of data, and it can be kept just in one JSON. And all of this functionality drops very often. They submine it from the bottom. And this high-end projects like Hive, Spark of Kafka, all of them are from Apache, and all of them are in Java in particular. I don't know why .NET has none, but maybe we'll see more. They submine the databases to make them less relevant at least. So kind of that's it. It's quite long, technical, but I hope you liked and you learned something. And if you like, please subscribe and write a comment, and see you next time. Bye bye.